All right, everyone. Hello. To use the new Bun FFI API to compile and run C from JavaScript, in our case, TypeScript. As soon as I saw Jared release this, I was super interested in if this could help speed up the auto routing algorithms that we build. So like, the algorithms that route these lines. Currently, there's a lot of obstacle detection, stuff like that. And we have these timings right here that indicate how slow or quick we're able to solve for all of these little red lines. And it gets quite complicated. If I jump ahead, we can see eventually you get hundreds, and then in real circuits, thousands of boards being routed. So I really wanted to see if this optimization would help us run that faster. And because we have a benchmark suite, we can see the before and after. So we'll see if this is kind of a viable thing. I hadn't, but anyway, let's go over the blog post. Let's see what Bun's all about. So it's version 1.1.28, compile and run C from JavaScript. So Bun now supports compiling and running C in JavaScript. It looks like we have to click here to learn more. I guess the rest of it we don't really care about. I love fixes. I still have a lot of libraries that don't always work in Bun, usually like fringe libraries. But most common libraries work okay, but that's great that they're fixing things. Okay, experimental support for compiling and running native C from JavaScript. And so we have a hello C program here, and then we have this TypeScript file. So this is a little weird to me that you have to give the path to a C file, because since I build everything into libraries, I don't know how that's going to work. So I'm like a little bit worried about that. I'd rather just give them a string and then import the string statically. But I don't know. We'll find out. Okay, he's clarifying it's better than the N API, which is a way to run C in JavaScript a different way, I guess. I haven't really run C in JavaScript. I am pretty familiar with this, though, where you have all these weird dependencies for every platform, and sometimes stuff doesn't run on CI because it was like built for the wrong OS. So I am looking forward to this issue going away. I don't know if there's, I was going to write, I was going to do like a Zig WebAssembly thing, but this is actually a lot better if it works, because I know there are certain functions that most of the time is spent in. Okay, cool. I think the rest of this is just going over how this works. Maybe like, very briefly, there's a couple things you can do that are pretty interesting. So in this case, we're just returning an integer and we indicate the symbol that we want to get out. So this function. But how we're going to use it today is most likely using, I think you can pass in pointers. See if he goes over that. Yeah, so you import PTR pointer from Bun FFI, and then you do convert file to MP4, and you give a pointer to your input, and your input is some buffer. So we're probably going to use this today. We'll try to convert our JavaScript problem into a static buffer, and then that's how we'll pass in data and maybe get data out. For us, it's really Boolean, most of the data we're working with. So I don't know if we'll need output pointers, but we will need input pointers. Okay, cool. So just giving a bunch of examples. My favorite part of this blog post is this last line. You probably won't get much performance gain from micro-optimizing small parts of your code base through C, but happy to be proven wrong. So today, I want to prove that this is wrong and that we will get a huge boost from optimizing a very small, like a single function call. For a very simple thing too, just obstacle detection. So hopefully I can prove this line wrong. I haven't done a ton of benchmarking to see what functions are the slowest, but I have some hunches. So hopefully I can prove that. Okay, with that, let's jump right in. And before I do too much, I'm going to make sure I get chat open, because I just realized I don't have chat open. Okay, cool. Now I have chat open. Okay, first things first, let's upgrade Bun to get the latest version. Oh, I can't make this any bigger. But it's just Bun upgrade. All right, we are all upgraded. I'm just doing some window management real quick. Okay, cool. Let's see. Okay. Nice. Okay, so we're upgraded. What I'm going to do before I do anything else is make sure I understand how this works. So we're going to play around with testing some different like objects into it. We're going to do a sample project. So I'll do bun init-y to get our sample project going. So we have an index file. Okay, cool. And we'll just be doing bun run index.ts. I saw this one import syntax that kind of confused me from the blog. I think it's some bun magic, but when they import, so this one, they just reference a local C file. In this one, they do source, and then they have a mp4.c file. So I think this just does a URL, or it gives like a file path link. I have no idea how that's going to like work with our build system. So I'd really rather just pass a string, but yeah, we'll play with it. So we're going to copy out an example. CC. Oh, what's going on? I thought it was CC. Am I wrong? CC. This could be a short video. I'm wondering if the types are not right. Types bun latest. Let's try updating our bun types. 1.1.9. I don't have CC. Okay. So I think we can hack around this, assuming it actually exists. But I do forget how this works. So declare Bun FFI maybe. This kind of sucks though, because I wanted to use those type parameters. What is this output? Symbols. Okay. Yo, what up? Keep going, man. All right. Appreciate it, Rahul. What up, Aditya? How's it going? Yeah, we're gonna try to get this working. I'm gonna fight through the type issues. Maybe Jared will come in and he'll be like, "What the hell is going on?" And he'll see this does not make sense. This is from my linter, I think. Yeah. So I'm gonna just plop in a biome file just so that it shuts up. I have like a lax biome. The other thing we need is pointer. Why isn't CC defined on Bun FFI? It's kind of strange. DL open. I'm just trying to see if like maybe I'm using it. I mean, this is, I don't know. Where is types bun? I don't know. All right. Issue for Jared. I think we can try to pull it off. But man, the thing I really wanted to know is if I could just pass. I'd rather have one file than two files here. But I think it's gonna make me. Okay, so we'll create a source C file. I don't know. I'll just call it program.c. By the way, I do not write C code. It's not my thing. I don't usually write it. When I do stuff with microcontrollers, I write it very carefully, but I do not usually write C. But I do like it. Like for a little bit of optimized code, like it's a very simple language. Okay, so source, I think that is imported the right way. I always have problems with this. I think it has to do with include. So maybe we include all the TypeScript files, and then we can include program.c. So maybe that'll get it recognized. Program.c. Cannot find module. Yeah, I always have this issue, and I always TS ignore it. I don't know. I don't know why it doesn't work. I really need some Bun experts to come in here and tell me what's what. All right, so symbol. Let's go to the simple example. Let's start a little bit more simple. We could do this. It's a little boring, though. Whatever, we'll do it. Some things I'm curious about. Can I print from C? Will it work? Will I see the output if I print things? Okay, so we'll adjust our C file. Maybe I'll keep the C file kind of down here. And then we give symbols, and we say my random returns int. Args, nothing. Okay. It's expecting 0 arguments because for whatever reason I can't give the parameters. I don't usually test code out the same day it comes out, but I was pretty excited for this. So I think there might be a couple things being worked out. Okay, so we get a list of symbols, and I can deconstruct that to get out my random function. Okay. Okay, include file stdio not found. So later in the code, he does this library thing. I'm going to try to do this library thing and throw in some libraries. So I think their blog post example might be wrong here. So stdio, stdlib. By the way, guys, not a C guy. All right, stdio.h not found. Do I need to have that file around? Errors while compiling test project. Include file stdio.h not found. All right, we've got no choice. Let's take it to Claude. What else can we do, right? Let's see. Let's take our. I think when you have this issue in C, I think it's supposed to be like your system has that. So this might actually be a system issue. Yeah, trying to include a standard input-output header file, but the compiler can't find it. Okay. I think Bun comes with it, though. Shouldn't, like, every system have stdio header files? Like, isn't that just, like, a thing? All right. Let's go deep, because I'm pretty committed to getting this somewhat working. Let's skip the docs. How can I use tinycc to build this C file? So we're going to make sure our C file works, which should It's from the blog post. I probably should. But this will help me debug if it's a system issue. Okay, TCC. Can I install TCC from brew? Maybe I already have it. TCC. I don't have it. Okay, so brew install TCC. Looks like it's there. An unsatisfied requirement. Interesting. Maybe I do have a system issue. Auto updating homebrew. This is the only way to install it. Maybe I just need to do a brew update. You know, what's up with cursor, like throwing this thing here? Get out of here. This formula does either not compile or function as expected on Mac versions newer than Catalina. Is it because of Mac OS? Yo, Shiba, what up? How you doing? We're gonna use Bun FFI to make our auto router faster, but before we can do that, we need to, you know, I can just use, what is it, Clang? No input files, so I do have Clang. Let's use Clang. All right, how can I use Clang to build and run this C file? So Bun FFI is a way to run C in TypeScript, build and compile C in TypeScript. So we're going to try to get that to work. Claude got cut off, but I believe I can figure it out from there. By the way, like, I've done these things, but I don't remember how to do these things, right? Oh, hey, we got something. Okay, undefined symbols for architecture ARM64. LD symbols not found. Okay. Neil's saying maybe you already covered this. You want to write faster autorouters with C? Yeah, what we're trying to do is there is a function in our autorouter which draws these lines, right? And there is a function that does a special obstacle detection thing, which we wrote about in a blog post called the intersection iJump autorouter. So there's actually probably a better diagram somewhere. Yeah, so there's these three functions. And I think those two are okay. This one, hitting a wall, we compute the next distance if you travel in a direction to hit a wall. And it's a really simple thing, but in TypeScript, like iterating over objects and doing all this stuff is kind of slow. So the time to do one iteration is a big deal in our autorouter because our autorouter takes very few iterations. It only runs these things like 500 times, but it still ends up taking 200 milliseconds sometimes on a big board. So the goal is to get that down. We have a benchmark test suite we can run, so it's a very fun way to see if we can make it faster using C. But we'll see how far this goes because I don't so far nothing has really worked with the new Bun stuff, and I don't know. It could be me or my system, but I don't know. I think it's a little beta. All right, the error you're encountering is because your C file doesn't have a main function. Oh, really? Oh, I guess you need a yeah, that makes sense. That checks out. So basically, like, you can't. Yeah, that's fine. It's a very unclear error. All right, program, random number, 92. Okay, so this is building. I don't know if we need a main. I don't know. It's probably fine. Let's see if TinyCC will build this now. So we'll run our TypeScript code that builds C. We still get an error with stdio. So I don't know. Maybe it wants me to drop in these stdio headers. I have no idea. To get this bun thing to work. But we know it compiles with Clang. let's just do a quick stdio. Any mention? No mentions of it. No mentions of this. We don't know. Maybe it's me. Maybe it's not me. I'm not giving up, though. Let's see. What can we do to try to force this to work? It is suspicious that I can't install TCC on... I'm on an M3 Mac right now. So the fact that I can't install it here makes me think this Bun feature might not work on maybe these ARM64 Macs. But I don't know. I feel it seems to me like Jared probably uses a Mac. I think I can find some evidence that Jared uses a Mac in his mentions. Somebody took a picture of him at a conference. Is there 2 R's? There's 2 R's. I need like mentions. I don't know how to do advanced Twitter search. Ooh, a lot of people complain. All right, I'm never going to find this. Anyway, I think he had a Mac. He's probably using a Mac. This should probably work. All right. Can we do this even simpler program, the Hello World program? So let's simplify everything. We're still asking for stdio. I could literally copy this exactly. Like, we don't have to do... Okay, I'm going to keep my type declaration, though, because that's going to annoy me that there's a little type error. Okay. Hello C not found. Yeah, we got to change this to program.c. I feel like stdio... how can I find my system's stdio? Oh, that question made no sense. I just realized. .h for including in C files. Is it there? No such file. Yeah, on a let's give some context. I'm on an M3 Mac, Catalina, I guess. All right, it's giving me a command to find it. Nice. All right, which one looks like the most plausible? This is probably like the most ridiculous way to do this ever, but I'm committed. I'm running some C today. I don't care. That looks pretty good. We're going to copy that, stdio.h. So now we have this file. Let's open this up. What do we just copy? It's a copyright Apple file. There's barely anything in it. This does not look like it's going to help us. But now we have it. Maybe we just don't need that include line too. I could just take it out. All right, it's still saying stdio.h not found. So let's just take it out. Implicit declaration of function printf. Yeah, because that's defined by the stdio.h. See if anybody's filed for this yet. Okay. So it's going to be like today. Nice. Yeah. Somebody reported it. All right, let's see what the convo says. This might be due to my macOS version. I'm upgrading and will report in a bit. Oh my gosh, do I have to stop to upgrade my version? Found that this worked. Oh, interesting. So this person just threw in an include line. You know what? I like it. Let's do it. Oh, this is a different project. All right. What do they do? Include. We also have to, like, this is some random path, so maybe we should just make sure that this exists. I feel like I was close to coming upon this approach. Okay. Let's do it. Oh, thank you. Somebody who understands C. Thank you. Jeremy. You can see they're basically doing the same thing. ChatGPT reports there isn't a likely folder to interact with. Ah, man, I love it. All right, cool. Next stage. All right, so yeah, we want to be able to call functions. So let's get that myRandom function going here. I'm surprised nobody is reporting the type issue. Is that just me? I don't get it. It's good to know that we can do returns void, because if we're manipulating memory, we might want to do that. But so let's do myRandom. And then we had to include something else. Yeah, we had to include that. And then we did int myRandom return ran. We could just return ran. I don't know why we got to do plus 42. Okay. We'll return int here. I think that's it. Change our return symbol to myRandom. And then we can do myRandom. And say logging myRandom. Or maybe like okay, let's run. Nice. Random number. Ooh, not so random. Wait, what? It's the same every time? Is that a tiny C thing maybe? Maybe there's pseudo-random. It might be pseudo-random. Okay. I think it's working. Cool. So we can run C with Bun now. So the main thing we're going to have to do is translate a problem where let's look at the actual, if we want to do some real work today, and just based on how long it took me to get that stuff, I'm a little bit worried. But basically, we need to convert the functions inside this class. So we want to create a class that uses C underneath, and it needs to, so it computes this obstacle list, and it has like the left, right, top, bottom, maybe the X and Y position of each obstacle. And then there's this function, get obstacle at, so that can probably be moved to C pretty easily. And you can see we're just doing this math, right? So we'll do some profiling and see if the C version of this is actually faster. That might be a good place to start. This one's not so complicated. The more complicated one is, I think, yeah, get direction distances to nearest obstacle. So what this does is it looks in every direction and it tries to find the nearest, like the next thing you're going to hit, which is much easier to understand when looking at a diagram. So actually, this guy's good enough. So what's the travel distance until we hit a wall? So that is like a little bit of math. It's not hard math, but it is, a lot of little computes. And then what's this one? Get ortho direction collision info. I think this is similar. So you get a point and a direction and some margin to be away from the obstacle, I guess. And then you compute there's a lot of math here. Moving within the same layer, only consider obstacles. Wow, I really need to write better comments. I think it's the same thing. I think it's the same thing. Is this used? Mac? Where's my Linux with i3 window manager? I apologize. I am Arch and i3 for life, but I sold out because, you know, it's just M3s are so fast. So fast. I also like, I don't know. The more it's almost like a issue with customization. The more I customize things, the more I forget how unique they are, and then I forget how to use them. So sometimes it's nice to go back to the non-configured world, but Linux is, you know, the best. Get obstacles with overlapping region. Okay. So basically all these algorithms do a bunch of math, and I want to see how much faster they get with C. So what we can do is kind of like extend this class and re-implement, but with C functions. And I'm trying to see if there's anything like they import that would be hard. This is the same implementation, but in 2D. Okay. Yeah, override this class. So this is basically meant to be optimized. I'm wondering if I need to do this inside of this code base or if I can move it out. I guess we can do it inside this code base. Okay, let's get started. You know, I should probably just test a couple more things. Let's go back to Bun and the FFI stuff. I want to test putting memory inside of the program, like sending it a bunch of memory, in this case all the obstacle positions, and then having it do some math. So maybe we can try to move the simplest of the functions over. The simplest I think is get obstacle at. This one is really simple. Actually, what we might be able to do, just to keep this like as simple as possible, we could just port this one and see if there's any speed improvement. And that would kind of tell us if we even need to go on to the other ones, because they all sort of take this form. Obviously, the math gets more complicated, and so there's possibly more stavings. In particular, I think like, you know, the math.min stuff and some of this might be faster otherwise. But maybe we can just try with this one function because it's pretty simple. So get obstacle at. We'll define this function. Maybe like what I'll do is I'll do the JavaScript version in its own file. Get obstacle at.ts. I'm going to remove the C file for now. Okay, cool. Let's just define that type here. Just trying to isolate this function out here. We can do grid step. Okay. So I think in this case, all we care about is an obstacle as a center, which is an X and Y, and then it has a width and a height. Okay. So 4 floats. This is just a biome issue. I'm going to turn off our biome warnings. Yo, what up, Rashab? we're going to see if we can speed up our autorouter using Bun's new foreign function interface. Biome is so crazy. It's got to have 2 instances running. So one time I save and format on save, remove semicolons. One time I save, it adds them. Biome. Maybe I need to add it as a dependency. It's confused because it's running on like a global and local version or something. That's just crazy though. Okay, cool. So what we're doing, we have our JavaScript version of this file. Now we need some test data. The best place to get test data would be from a really hard auto-routing problem so that we have a representative data set here. So, how can I get that really, really easily? Let's run the auto-routing dataset project. Just get ourselves a really big data set, a really hard problem, maybe one that the auto-router doesn't even successfully do, or nearly doesn't successfully do. So I'm just gonna go up to this. Oops. I'm increasing the sample count. Nice. I hope we get some improvements. I do too. Okay, so it looks like it was correct on this one. This is a nice meaty problem. We've got a lot of lines here, a lot of obstacles to detect. I don't know how many obstacles are here, but it's a decent amount. So there's 2 things I could do. One is I could download the sample, which is this left side one, or I could download the right side one, which is almost better. The right side one has more obstacles because there's more traces. Traces become obstacles for other traces. So I'm gonna download the right side one. And now we have this big JSON object. So let's see if we drag it over to this guy, just plop it in here. So this is the circuit JSON file format. And there should be a function that lets us convert that into a list of obstacles. Let's see, get obstacles from circuit JSON. Yeah. I'm trying to see if I can isolate this function. It only imports this one thing. It might also be something that's exported in a different module. Just data pipelining. It's more fun when you set up a really intense problem. So just a little bit of data pipelining. It's going to take 2 minutes. Let's see. Multi-layer iJump. I'm trying to see if one of these algorithms actually exports this function. Let's just do it. So I'll do bun add TS circuit infgrid iJump a star. And then I'll create a file, sample obstacles.ts. Do export const sample obstacles equals get obstacles from circuit JSON. Nice, it is exported. And then we'll import that JSON file. Just for fun, let's take a look at the data and make sure it looks good. Sample obstacles.ts. Cannot find package debug. It's a transient dependency. That's not right. More transient dependencies that aren't marked. It's more of a TS circuit problem. More transient dependencies. There's probably gonna be like 5. Let's see. Okay, performance now, we need it anyway. That's how we're gonna measure performance. How many more? All right, this is the last one. math utils. Wow, there's a lot. This is what happens when you don't list your dependencies properly in the dependencies field. All right, got a bunch of obstacles. How many do we have? They look good. There's no nans, so happy about that. 403. So 403 obstacles. That's kind of the size of the loop. So theoretically, the C implementation would be way more performant as that got higher if there is overhead to JavaScript calling it. But JavaScript also does magical things. So maybe you want it. Let's find out. Also, like, it wouldn't be fair if I didn't benchmark in both Node and Bun, because Node uses V8 and I don't think Bun uses V8. So we have to test JavaScript V8, Bun, and then Bun with FFI. And that's the only way to make this like a really fair comparison. And this is a pretty simple version of our problem too. So I think if there is any gain, it's going to get multiplied as we do it to more complicated functions. This is like a pretty simple function. Okay, so we have this type representation of an obstacle. What we don't have is a version that can go into C. So we'll need to do that. We also need a function that benchmarks this in just JavaScript. So let's do that very quickly. I'm actually going to write this as a JavaScript file. So we'll say benchmark js.js. And that way I can run it directly in Node when we need to. Oh, no, I can't do that, actually. I will have to build it because there's so many TypeScript files here. No matter what, I'm going to have to build it. So let's just do it in... Okay, cool. This would be helpful only with circuits with a lot of obstacles, right? For simple circuits, the overhead of calling C would be more. There's barely any overhead. The overhead of calling C is 2 nanoseconds. And these functions aren't called, like get obstacle at is called probably like is called once per iteration. So with most of the auto-routing dataset algorithms, we measure the number of iterations it takes to get towards a solution. So being called once per iteration is not, 2 nanoseconds is not a big deal. It's not called for every obstacle. If it was called for every obstacle, the nanoseconds would really add up. But yeah, they're not called that much. So yeah, it's not a lot of overhead. The other thing to keep in mind, I think, is that a lot of people talk about like milliseconds and nanoseconds. Those are like the 2 units. I think like we forget that there's a unit in between, microseconds, and nanoseconds are really small relative to milliseconds. So right now we measure our auto-routing algorithm's performance in milliseconds. So if it goes to... If Bun is measuring their thing in nanoseconds, like it's not going to be a lot of overhead. So how do we want to do this? I have to be really careful because if we use like let's do this. Let's pre-compute all the points we're going to test with. So we'll do I don't think 1,000 points will be enough. How many times is this called realistically? So per trace, our normal iteration count is like anywhere from 3 is very common, to like 500. And then if you have like 10 traces, I think 10,000 is pretty good. That's how many iterations you probably run on the average circuit. And yeah, we can just do X and Y. I'm going to subtract 50 from this because the range is roughly -50 to 50 for these. Okay, we can go through the points, get obstacle at. Yeah, okay, sounds good. Let's see how that runs. I forgot to import. Undefined is not an object. Evaluating this dot obstacles. Okay, I did something very wrong. Yeah, you need to take the obstacles as a parameter here. Okay. All right, 6.5 milliseconds. That sounds about right. That reflects, like, if you look at like how long this took 14 milliseconds, and it has 400 traces, and there's a lot of other functions like this being called maybe 10 times. So that is pretty perfect. So I think this will be pretty representative. Cool. Okay. I'm just going to do 2 fixed, not 2, but like 4. Let's make that a little smaller. Yeah, and it looks like it's like plus minus 0.4-ish. It'd be fun to see how V8 handles this. I don't know how we could do that. We could maybe use TS node. I don't know if TS node is representative though. I don't know if it has like some kind of weird overhead. Let's find out. Oh, unknown file extension. What are you talking about? Do I have TSX globally? I don't have TSX globally. Let's use TSX. So just another way of running a TypeScript file, but I believe this should use V8. Oh wow, V8's faster. Yeah, this is one of those things where V8 is actually faster than Bun if you have like enough iterations. But people really like Bun because of the cold start. We haven't done anything yet. What I did is tried to replicate the conditions of routing a circuit to guess what the impact of porting it to C would be. So right now, we only know that like Bun is a little bit slower than V8, and now we're gonna write a version in C, and we're gonna see if the C version is faster than both of these, which it should be. But we can kind of document. We should document this a little bit because it is difficult to keep track of the numbers. So Bun versus Node V8 versus Bun FFI with C benchmarking. M3 Mac Pro results. We're just going to keep this really simple for now. So Bun, I guess we could say test setup. Whoops. Setup 400 obstacles. It's a representative circuit auto routing problem. I think it's 411 actually. 411 obstacles, 10,000 random points. Compute if the point is in any obstacle, and return obstacle. Okay. So in review, Bun, I'm just going to take the first one, the first benchmark that happens here. Bun 674. We'll refine this at the end to get like more precise numbers. Node. It's probably surprising to people that V8 is faster, but V8 is like optimized like crazy. What just happened? Oh, I accidentally ran the TSC instead of TSX. Okay, there we go. That is expected. Bun has super fast start times, but is not always the fastest for pure JavaScript problems. Bun FFI, that's what we're trying to figure out right now. The 14 seconds was the actual time. So right now we're just it's not 14 seconds, 14 milliseconds. So still very fast. So that's the actual time to route. And what we've done is taken some functions from the auto routing data set and moved them to this repo to try to get something that's fairly representative. Yeah. So yeah, it is a little bit complicated, but instead of porting the entire obstacle algorithm over all at once, I'm going to try to judge what the impact will be before we do that. Because if we port the whole algorithm over, we might spend a tiny bit of time debugging and all of this, but we won't have to. It'll be a lot easier with this approach because there's in the actual auto running function there were 4 functions we need to emulate, but here there's only 1. But it would be very easy to take this work and do it. But let's figure out if it's worth it, right? So, so the next step is to actually implement this in C. I'm going to open up my files here. We've kind of got a mess of a directory. I also accidentally compiled all the TypeScript files to JavaScript. So let's delete those. Avoid confusion. Let's delete our compiled program. Don't need that. All right. We're looking all right. Maybe I'm going to make a source directory and just clean this up for 5 seconds. Save us a lot of brain power. Okay, move this, move this, move this. This index file kind of is a little bit random at the moment. I don't like how this is referenced, so maybe before I refactor too much, let's make sure that program path from... Yeah, we'll do program.c as type file. So this should turn it into a file path. We're going to TS ignore it because TypeScript doesn't like it. And then let's move this into assets, this JSON file. Okay. Very slightly cleaner. Oh, and sample obstacles too. Okay. I'm accidentally making a real project out of this. I kind of didn't want to. I wanted to do this benchmark in like 5 minutes, but we ran into issues. Oh, our TS config is messed up too. I don't know how anything's working with this. Let's just remove it because it didn't help us with anything. Our modification to it. Complaining about, oh, it's width. It's the right. Still got that error though. Okay, let's try running this. Make sure everything works. Bun run, source, index. We'll also rename this. Yeah, all right, we're working. So I'm gonna rename this to, let's call it get obstacle at with C. And then we can do a benchmark-c file that will import get obstacle at with C from get obstacle at with C and run the same test. Okay. So I feel like we've got a good direction now. We know what we're doing. All we need to do is get this file to export a function, get obstacle at with C. And it's okay for us to preload. I should have said this earlier, but it's okay for us to preload obstacles because you can do that in the actual algorithm. So let's see if we can preload some obstacles into this. To do that, we have to go to the blog post. And he does it at the very bottom. This I actually didn't really think I could use this at all until I saw him using pointers, or whoever wrote this blog post. So pointer account, and that is a buffer. So that's how we can pass stuff in. So now I need to do some cfoo where we have a buffer. Maybe we can use one of these things like big uint64 array or something like that. And we need to store them as floats and then read them out. We need to store 4 values. So we're going to pass in a big matrix. Okay. Lot going on. Let's get to it. Instead of my rand, I'm just going to try to do this all at once. It's probably going to fail, but let's do it all at once. So the first thing we have to do, I think, is write some C. So we're going to call this get obstacle at with C. It's going to take in a float star star. Do we have that? I don't know if we have that in C. I think we just have this, and then you have to... Let's do this. So we have our obstacles, int number of obstacles, and then we have our float xy. Yeah. Luckily, ChatGPT, or whatever I'm using, Sonnet, is trained on tons of C. So, okay, and then we need to port our algorithm. Yes. Yes. I don't know about this x1, x2 thing. That's not how we do it over here. So I'll try to stay true to what's going on in here. This is the method we're porting. Looks like it also takes a margin, so I guess it's only fair that we also take a margin. So I'm going to add this to the input here. I kind of wish I had made this whole thing a prompt for O1 preview. Like the entire, like, give me the Bun code. This is what Bun released. But I did not do that. Right. Actually, but this part is just writing C, so let's ask Claude for this. Can you finish this C program? Ooh, I don't know about using structs. Because I don't know how we could pass in the struct. Can you do it without structs? Maybe the obstacles could be like a matrix where each row is 4 columns and 4 columns x, y with height. All right. Cool. I don't know if C supports this. Does C support the double obstacle, the double pointer thing? Even give us a function here. Sorry, I just if this works, I'm just gonna be amazed because I don't know. Like I write C, but I usually write it very gradually. It's not really compatible with my hyper fast like AI development style. Normally, I take a long time to write my C code. So I'll be pretty amazed if this works. All right. What did I just paste? That's not what I wanted to paste. I'll just copy the whole thing for now, and then we'll adapt it as needed. So we don't need this Maloc stuff. And I guess we don't need... I don't know why we need stdio or anything like that. Okay. Oh, that's cool. It even handled the optional, but I will actually handle this out of band. I feel like encoding your defaults in C is a bad idea. And we return -1 if nothing is found. Okay, sounds good to me. You know what? I love it. I think it looks great. I am eager for it. I feel like I could be wrong, but in C, isn't this variable assignment going to cost us? Maybe TinyCC does this optimization already, but I think we're like, I feel like this is going to cost us. Oh, it even handles layers. Did we handle layers in our get obstacle at function? Oh, we do handle layers. All right, get obstacle at with C. So that's what makes it 3D is you have multiple layers. So this is actually a 4-column array. Where, okay, maybe just a little snippet of documentation here. Obstacles is a 2D array of floats with the following structure. Sure. Yeah, perfect. It's a little weird that layer is an int, or a float, but that's not going to cause any problems. So I'm just going to roll with it. It's like 1, 2, 3. It should be an int. It's as a float. All right, cool. So we have our C function. Let's fix the symbols. Get obstacle at with C, returns int, args. Yes. Okay, let's try calling it once. But so the construction of the obstacles is going to be the initial most challenging thing. So because what we have to provide this thing. I don't even know if Bun will let us provide that thing. Let's see if we can even run this. I spelled obstacle wrong. Obstacle. Okay, we got an invalid arg warning. Unknown type float. Okay, so my understanding of pointers is we can use just float and it should still work. Unknown type float. Can I clang this? Oh, no, because we need that main function. Let's do a dummy main function. Or clang source program.c. Clang built it. I think float exists. I know sometimes there's things like, you got to do like float. Oh, I forgot. We have API documentation too. I've totally forgot about this. So this might have some information we like. Or not. Extern C. What is this? What is going on? Oh, this is how you... Oh, this is like not stuff we care about. Function pointers. Oh, maybe it is. Wait. What is this? Somehow you got this pointer. Get version, C function, return C string. Pointer, my act. Oh, interesting. Oh, huh. Weird. Well, this is over my head. But looks pretty cool. So we have pointer, unit. Okay. Is there a float? Oh, these look like types. FFI type F32. Well, we're on a 64-bit system, so I think I can use F64. Get obstacle out with C, F64. Unknown type. In their blog post, they use pointers. Oh. When they use args C string. And then PTR. Can you see that? Okay, cool. So all pointer types are the same. That's fine. So now we have to create this is the part I dread the most. Float 64 array. Oh, this isn't so bad so far. Elements. Wait, I don't think this is going to be bad at all. Okay, so we go through our sample obstacles. We can do a flat map. Yeah, just like that. Do we have a layer? I think I forgot to do layers, so we're just going to ignore layers. I don't think it's that big of a deal. We're still doing the check, so I think it's fine. Cannot find sample obstacles. We'll import that. I think it's great. So now we have an obstacle array. If we go to our import at the top, CC, we can do pointer, and then we should be able to pass that in as the first argument, and everything else is easy peasy. So let's see if we can do a single call of it. Get obstacle, let's see, with PTR, obstacle array. Yeah, at 0, 0. I don't know if we'll do the width and height as 0, because that can't exist. Oh my gosh, cursor. Leave me alone. Unwelcome recommendations. Why does this not look like the right number of parameters? Int. Oh, number of obstacles. That's very important. So number of obstacles is sample obstacles.length. Okay, here's what I'm going to do. See. I'm going to call this get obstacles with C. It's a little messy. I think what I want to do is, get obstacle at, I think I need kind of like a curry here to make this like clean. Get obstacle at with C, direct is what I'm going to call this. Direct. And the reason I'm doing that is I'm going to make a version of get obstacle at that doesn't require these two first parameters because it makes it really messy. Okay, and then it says float here, but it actually is float because there's 5 things you have to provide, I think. Number of obstacles 1, 2, 3. No, it is 4. 1, 2, 3, 4. Okay. 1, 2, 3, 4. Okay. Yeah. Okay, let's see if it works. Oh, nice. Segfault. Okay, I think I know why. I just have a hunch that I'm passing in this flat float array, but it wants an array of pointers. So I think I just did bad C. But very, very easy to fix. So instead of float star, we do this, and then I just add the index. It's just like, college C programming. Okay. So basically the same thing. Nice. Oh man, that's pretty cool. All right, let's go. That's pretty cool. So the next thing I mentioned is we have to curry out that function or whatever. I don't know if I'm using that right. So we're just going to export a function that has those first 2 parameters ready to go. Yeah, I knew exactly what I wanted. There we go. Okay, cool. Now we can run the benchmark. We'll have to check the results too. So I'll check for correctness somewhere else. I don't want to check for correctness here. I think we're ready to go. Everything is set up. Cannot find module get obstacle at with C because there's a typo. Obstacle? Wait, there's not. Get obstacle at with C. Get obstacle at with C. Oh, it is. Okay, I don't know. What are you complaining about? Oh, yeah, because I changed the signature a little bit here. The signature, not a big deal. Okay, let's run it. Source get obstacle or benchmark dash C. Moment of truth. Oof. Oh. Same amount of time. It's basically the same. Let's take a look. It's disappointing. It is faster, but not much faster. I wonder where our overhead is. Man, that's crazy. Why is it? What? Is it because of all this like function stuff I'm doing? Let's do a little bit of math based on that blog post. So, if it's taking 2 nanoseconds, which is 2 to the -9, and we're running it for 10,000 points, this is disappointing. But it might not be. You know, who knows? Who knows why this is happening? Let me just take a look at this benchmark. 10,000. We're running it for 10,000 points. So that means, yeah, our total overhead for C calls is negligible. Maybe it's the currying. Let's get rid of the currying. And you know what else? I just realized I'm creating pointers every time. So maybe I have just put too much stuff in the middle, and when you're doing a lot of optimization, you don't want stuff in the middle. So let's do it. So get obstacle at with C. We're going to store this pointer ahead of time. Okay. See if that changes anything to get us started. Wow. That did change things. Creating that pointer, I guess when you're running one function over and over again, it really matters. So let's try getting a little bit. Let's remove this currying call, and we'll have a slightly messier method signature, but like, you know, we don't care that much. It's not that much worse. Okay, so, where's my benchmark function? There it is. So we're going to use the direct version. Ooh. Cannot find, this needs to be imported. Okay, try again. Cannot find variable x. What am I doing? Point.x. Some days I can't type and I don't know why. All right, and we're just going to hard code the margin 0.1. Point.l doesn't exist. I don't know. It's the layer. Looks about the same. I don't know. Maybe C is, maybe, you know, JavaScript is really good at these pretty simple things. I'm still kind of surprised, though. I don't know. Well, you know, they did say it in that blog post. Don't be super surprised if it doesn't give you improvements. So we're iterating over each obstacle. Yeah, it's just it's pretty simple. Where do we go from here? This code is just the same speed, basically. Or just there's other like JavaScript function call overhead that's taking up most of the time. So like another way to do this, but this would not be realistic for how the algorithm works, is to like preload all the points so that all the points are in an array. But that wouldn't be realistic for how the algorithm works, because the points are constantly changing. All right. I don't feel satisfied yet. I think what I'd like to do is test out the C function speed. Just like run the C function. I'll use Clang and see how fast it is if I just execute with 10,000 points in pure C. But I don't want to write a lot of C code, so I'm going to ask Claude to do most of this. You know what? Let's use... Ooh. Let me see what's going on here. Did I cause a ChatGPT problem? I wanted to use O1 preview. Okay, cool. Yeah, all right, we can use O1 preview. It was asking me, I just upgraded a ChatGPT team, and it was like, oh, how do you want to migrate stuff? So let's set up this problem inside of a Scratchpad. So I will open a Scratchpad, and we're just going to write all the details for it. So please port the following benchmark completely to C. Don't worry about outputting the amount of time. We'll do that when we run the program. So I will paste in the TypeScript code for benchmark C. I think the most annoying part of this is I somehow have to get these sample obstacles out into a format that can be read by C. That's not what's inside of there. Just gonna put them all on layer 1. Okay. So this will output a really big array. Let's go to Claude real quick. In C, how do I define a big array of float? A big array of float. Uh-huh. I am worried about, I don't know how to profile in C. I'm learning a lot today. How am I doing with the Bun FFI? Well, so far we don't have a speed improvement. These are our benchmark results with this this get obstacle function. And Node is actually faster. Node is able to optimize the JavaScript to be faster. So what I'm trying to do right now is figure out what is just the speed with C to try to get to the bottom of what's the overhead. I thought this code would be just instant with C, but apparently it's not. So figuring out how to, basically make it instant is my next goal. For defining this, yeah, but like statically, like if I want to put the data in C, what I'm going to try to do is copy and paste like a giant definition of the big array. Yeah, just like that. Yeah, so we will basically just literally inject that into the file. I'll create a new file. So program.c, we'll do C benchmark C only. And we're basically just going to define this thing. I think I do have to run the benchmark inside of C because otherwise like any initialization cost will accidentally be captured. So float obstacles is equal to this. Yo, what up, Abby K? Yeah, okay, cool. So we're logging out these obstacles. I think if I do like map and try to put it in a C-ish format, like that, it should work. This is going to be a very ginormous file because that's going to have like, I don't know, 6,000 lines or something. But I just want to get to the bottom of this. Why is the Bun C code slower? It doesn't make sense to me. All right, there's our big array. Maybe we put it all on one line. Bro, what the hell is coding? I don't even know the C of coding. It's like hell to me. How do you do things so fluently? I use AI. That's it. That's all there is to it. Man, I can't remember how to put things into a clipboard on Mac. I think it's like PB copy, maybe. Okay, so we're just going to paste this guy on top, not of this file, but of this one. Nice. Why is it complaining? Do you have to, are you kidding me? Do we have to have the, we have to have a dot? All right. So then I will do 2 fixed, 3, something like that. So it's not going to be perfectly accurate, but I don't think it'll matter. And then I'll paste this in again. Okay. So now we have all of our obstacle data preloaded into C. Is this your first live stream on this channel? No. Actually, if you go to blog.tscircuit.com and then you click dev streams at the top, you can see all of the streams. I try to do dev streams daily. Usually it's TypeScript, but today we're doing a little bit of C code because Bun just released their new C API. Identifier I is unexpected. I think I'm confusing the syntax highlighter with this giant object. Or maybe I'm not defining this totally properly. Oh, I need a semicolon. Okay, cool. Now we need to write the benchmark. You are like an alien to me. How do you even understand this language? C? I don't know. C's pretty popular. C's pretty popular. A lot of courses on C. All right. So I don't think yeah, all right. You know what? F it. Let's go to our scratch pad. So we gave it the benchmark. Port the following benchmark completely to C. Don't worry about the amount of time. Okay, I do want it to worry about the amount of time. I'm just going to say port the following benchmark completely to C. And then I'm going to give it the C code I wrote. And I don't think I've exceeded the context window. So I think it should be able to do it. And we're going to use O1 preview for this because why not? So O1 preview is, you know, I think it's the best for doing complicated things. A lot of people say Claude is still holding up there, but how long have you been in this field? I don't know. I've been doing web dev for like, I don't know, 13 years, 14 years. Very long time. Oh, it didn't set up random points. So it's also doing the random points for us. That's good. Certainly, below is the complete C code that ports the given TypeScript benchmark. This generates 10,000 random points. It's not copying my obstacles over, which is fine. Okay, num points. All right, that's fine. Okay, so this is the part we want to copy. Damn, you are hell genius. Thank you. Thank you. I am not, but thank you. Okay, let's paste this, and then we will compile this program with Clang. Benchmark C only. Benchmark C only. Error, called an undeclared function get time of day. Maybe I missed an include at the top here. Yeah, I missed some includes. Do I have a LinkedIn? I do have a LinkedIn. I think you can find my LinkedIn if you look at my name. I have a very unique name. Not many people have it. All right, we successfully built this, so now let's run the benchmark only. I don't know what it's going to output, but 18. What is this? What is this madness? It must be profiling maybe the generation as well. Get time of day, start. It's starting here, going through 10,000 points. What is going on? I am so confused. I don't know. Maybe I'm bad at benchmarking. Yeah, that doesn't... I mean, it is possible. It is possible because JavaScript does a bunch of, like, you know, special things to make it go fast. So it's definitely possible. But I'm having a hard time believing this. 10,000 points. Get obstacles with C direct. Is this really the right way to profile with C? Get time of day? What if this is... You know what would be plausible if this was not actually in milliseconds? Like if the conversion is somehow wrong? Let's try asking... let's ask Claude. What's... Maybe just like... Just take it from the top. How do people usually benchmark C functions? It's actually very possible that it's slower. They do say get time of day. Yeah, can you show me a simple benchmarking file in C using get time of day? Now we know why Jared gave his warning that it probably won't speed up your programs. Start and end. Average time. It is in microseconds. Average time over D runs in microseconds. Okay. Trying to reconcile this. Yeah, I guess C isn't always faster. I wonder if Clang has some optimization that we can use here. Can you make a playlist for beginners? I am not a playlist maker, you know. That's like I'm more of like a programmer, you know. That puts me into a bucket. Okay, so how can I improve the Clang flags for a more optimized program? And then I guess we can like, I almost want to give it the program so it understands like, let's do this. '03 March, what did the heck? Okay, all optimizations. Optimized for specific CPU architecture, okay. Aggressive floating math optimizations. Oh my gosh, what the heck? Some of these feel like cheating because it might be able to statically analyze. Like this one I'm particularly worried about because it might be able to statically analyze the size of the obstacles, which would be actually cheating because the number of obstacles could change. Link time optimization, whole program optimization. I don't know what that is. Let's just start with '03, and then the architecture native sounds like a pretty like reasonable way to do it as well. Wait, what? Hold on. Okay, it went to 0. Okay. All right. Losing my mind. What did I change this program somehow? Hold on. Oh my gosh, this is ridiculous. Yeah, okay, so 15 and then I add 03. All right, so those flags really matter, it turns out. Flags are very important. I'm going to output, let's see. Why does it multiply by 1,000 here? Elapsed time in milliseconds. So this is natively in what? I just don't like how this is written. Let's say elapsed. Because then it does another... Oh, wait. Divided by 1,000 times 1,000. So elapsed is... Wait, why are they adding? What is going on here? Shouldn't it just be... end minus beginning? Why is it adding to the elapsed time the difference again? This is so weird. I need to look at my reference program from I think you just do this. I'm gonna output this to get started. We're going to output it unoptimized. We're going to look at the value. Why is it 0? Okay, I think that one is in seconds. So to get to milliseconds, you would just divide by 1,000. Oh, no, sorry. You would multiply by 1,000. To add more decimals here. What is going on? Seconds to milliseconds. Okay, I am now understanding these comments. Seconds to milliseconds. And then what? Yeah, something is really weird just with this specific portion. I'm going to ask Claude to just fix the elapsed portion calculation. Yeah, something's weird. The current calculation is close, but it can be improved for better accuracy. What are you talking about? What? I feel like I'm crazy. What is TV sec? It converts the difference in seconds to milliseconds and adds the difference in microseconds. Oh, this is TV sec, and this is TVU sec. So I guess it is right. Yeah, that's another way to do it. I think the problem is it's like a double precision. It's like a super precision thing or something. Wait, what is the unit of start? It's this time val. So a time val has microseconds and then seconds. And so you have to combine microseconds and seconds. So I think it is correct. What I didn't see is this one is sec and this one is U sec. So I actually think it's okay. I'm a believer again. So 16 milliseconds. And then if I do -03, it's 0. But 0 is pretty small. So let's add more. Okay, I don't know. Do we actually believe it's 0 here? I think maybe the optimization is removing the loop altogether or something. You know what I mean? It's like, oh, there's no effects in that loop, so it can be removed altogether. Let's try 02. Let's try 01. Yeah, I don't know. When I use the -03 flag on this function and compile this program, it says it took 0 milliseconds. Why? Compiler optimization, aggressive optimizations, significant changes, dead code elimination. Yeah, it doesn't affect the program's output. Okay. This is a little bit of a cheat, but why don't we just like make this affect the program's output in some way? So we'll say like int. Yeah, results. That's a pretty good way to do it. So we're kind of cheating. We'll do some results assignment, and hopefully that's not too expensive. But like, if we don't do this, it's like it's going to get optimized away. And then it could also eliminate this. So maybe what we could do is at the very end of the program, we can just like somehow print. I don't want to print all the results though. So print the sum of the results. It's something like that. Like basically we need to force it to do the calculation. All right, there we go. So now we're doing a little bit more stuff, but we are seeing some speed improvements. Okay, so we're finally faster. We did have to do some other stuff. I wonder. Let's just calculate this on the fly here. I don't think it's going to be faster, but it is a little bit less stuff. All right, cool. It is all over the place. Plus minus 2 milliseconds because our first one executed. All right, we can add a couple other flags. And then when it's off, we're still at 16. So we are seeing a lot of optimizations there. But I think what we're seeing is that the overhead is pretty high with the Bun program. Even if... Yeah, I don't know if the 2 nanoseconds thing is really the biggest part of the overhead. It seems like there's other overhead that's a little bit more difficult to consider, and that's why it probably isn't speeding up the program too much. Let's try adding some of these other Claude, these flags that they recommended. So 03, architecture native, could be interesting. So these are things, you want to get from I think, using WebAssembly or something like that. So we basically can't access this stuff. That did nothing. Fast math. I like it. That seemed to... Yeah, I mean, I think it's the same. It might even be slower. Omit frame pointer. I don't know. I don't really think anything else would be super useful. Consider using const for parameters that aren't modified. Oh. I don't know if this is cheating. I think it is cheating. That's a good question. It uses tinycc, so I don't think it's possible. We could look, but I don't have types right now for it. So we'd have to like find in the Bun FFI docs, but it uses tinycc, so there's no way it's going to have like serious optimization flags, and I think they mentioned that. I feel like we're also like kind of looking at the cold reality that like, you know, like you can only make an auto router so fast because there's so many checks you have to run. It just randomly took 11 milliseconds. Okay. So anyway, I feel like I'm trying to find like the least disingenuous answer for our README here. C only. I think it is getting as low as 3.27, but that feels a little bit dishonest because it's usually more like 4.3. Yeah. I'll say plus minus 1 millisecond. That makes me feel a little bit better. Yeah, it's not like a super great benchmark. These were also all over the place, but pretty interesting. We didn't port some of the more complicated C functions. So I think like the next step of figuring out can our autorouter actually benefit from having some C calls would be to take out a different part of it, like or a more complicated function. The more complicated functions, we ported the get obstacle at function, but the more complicated one is get direction distances, where it kind of does a little bit more work and it has some min and max. So I think we would almost want to see what the impact of these are on the algorithm and then see if it makes sense. But yeah, it's a little bit, you know, I guess don't underestimate JavaScript core or V8. They are very fast and very good at understanding, like, I guess, yeah, understanding what your code is doing. So I think that's that. I'll push this repo somewhere if people want to kind of be critical of the results or something like that. But that's definitely given me a new understanding on how fast things can run. We'll call this Bun FFI benchmarking. Okay. I should also probably give the C flags that I used to get this time. You know, only, and then the only one that actually mattered was -03. Clang, -03, source, benchmarks, yeah. I'll just say running benchmarks. C only, and then each other one runs in different ways. So the other ones are just like bun, run, source, benchmark.ts, I forget, benchmark js.ts, benchmark C, and then we have the TSX. So npx TSX. So this one uses, this is the Node V8. Node V8 is kind of the winner here because it's a lot of work to port things to C. But I don't know, I don't know, maybe things will get better. Okay, I don't want to commit some of these random binaries. So let's get these out of here. Hey, Sevi, how old are you? I'm not going to say that on stream. Good night. Great stream. Learned some things. Thanks, Rashab. Good to see you as always. Initial. The greatest. First commit. Okay. And that is basically it. This repo is up. Maybe I'll do a tweet after this, but good stream. Thanks for coming, everybody. I think we learned a lot about Bun FFI. I'll post this later on the TS Circuit blog. If you go to blog.tscircuit.com and dev streams, you can find all of our dev streams and subscribe to our newsletter, stuff like that. But thanks for tuning in, and see you soon.